Today we're going to talk about 2.3 Island Biogeography. Continuing with our same themes and the big ideas in environmental science. So island biogeography. By the end of this lesson, you should be able to describe island biogeography and describe the role of island biogeography in evolution. To accomplish this goal, we're going to describe what island biogeography is, describe the factors that impact the biodiversity of island ecosystems, and lastly, look at the relationship between island biogeography and evolution. So island biogeography is the study of species composition and species richness, so we learned that in the last one, of an island. So this is determined by two factors: the rate at which new species immigrate, so come to the island, and the rate at which species become extinct or are no longer on the island. And this was found by E.O. Wilson and is a theory that's held through with lots of different studies. So here's what appears to be an overwhelming graph. We're going to take it piece by piece and come up with some explanations for how we can classify the diversity of different islands. So we've got two sets of lines. The first is the rates and probability of colonization, so things appearing on the island, and the rate and probability of extinction. So we are going to look at what happens when you're close to the mainland and when you're far from the mainland, and on small islands and on large islands. So beginning with just the probability of colonization here, in islands that are close to the mainland, they have a higher rate of colonization. So they're going to have more organisms appearing on the island versus these ones that are farther away. And we think that's most likely because it's just more difficult to get to. The further away you are from the island, the fewer species that can swim there or fly there or be blown there on the wind. On the other hand, we're going to switch colors. We've got the probability of extinction. So small islands have a higher probability of extinction. Larger islands have a lesser probability of extinction. So let's relate this back to biodiversity and the idea of habitat diversity. Smaller islands are going to have fewer habitats. So by virtue of their size, you're going to have a lesser diversity in the types of habitats that you're going to have. Therefore, if you have more species there, you're going to have a higher rate of extinction because they can only support so many different species. And if we think back to resource partitioning, if the species don't diversify and find different ways to use these limited habitats, they're going to go extinct. So we can generalize this to say that closer islands that are larger are going to have more species than smaller islands that are further away. Again, because of the resources they offer and the difficulty to get there. Going back to specialists and generalists, remember specialists can only eat a limited food, they live in only one habitat, and they tolerate a limited range versus our generalists, which kind of are jack of all trades. They eat many foods, they can live in wider habitats, they tolerate wider environmental conditions. So on a small island with limited resources, or really any island, which species would you expect to find? Specialists or generalists? So we're going to see specialists appearing on islands, particularly those with limited resources. So an example is the fire crown found in Juan Fernandez Archipelago in Chile. So if you only have limited resources, as we said before, specialists perform very well when their habitats are stable because they're so specialized to the resources that they have available. This is great, but they're at risk of extinction because their long-term survival can be jeopardized when invasive species, which happen to be typically generalists, are introduced to these islands because they can overtake so many different habitats so quickly. So a great example of that specialization within islands is the Hawaiian honeycreeper. So originally only one or two species was able to get to the Hawaiian Islands. So remember, you have less species diversity the further away you get because it's harder to get there. So originally one or two species showed up, and now we have over 56 unique species of honeycreepers, much like the finches that Darwin categorized. So to summarize, biodiversity on an island is a product of its distance and its size. Larger islands are more diverse because they have more habitats. Smaller islands, less diverse, less habitats. Closer islands, more diversity, easier to get to. Farther islands, less diversity, harder to get to. Islands are colonized by new species that arrive there, like the honeycreepers. New species had to get there so that they could be colonized. And that species typically evolve as specialists on islands because of those special habitats, and they are at risk of extinction from generalists, which may arrive on the islands later.